After illustrating the expanded form using the binomial theorem for an expansion of any binomial expression, let's try to look into this given. We have here the binomial expression x plus y, and the exponent is 25. But we simply ask about the numerical coefficient of the term having the literal coefficient x to the power of 12, y to the power of 13. Now, if you would like to use the binomial theorem in expanding this, of course you can, but we are expecting a lot of terms. Our n here is 25. We are expecting n plus 1 terms. In short, you will have 26 terms for this given expansion. As mentioned previously, you can actually use the binomial theorem to look for the expansion, or if you're simply asked about the coefficients, you can automatically get the result even without expanding that. This is now the first example, and we will have a lot more later. Now, the expanded form or the binomial expansion has this notation. We have the summation of n taken r, x to the power of n minus r, y to the power of r, as r starts from 0 to n. Simply take the value of n, which is 25 in this notation, and look for the value of r. That's what we would like to look for. And after that, you can simply look this result here and take actually the numerical result of that as your numerical coefficient of the intended question. Now, to do this, let's know that the numerical coefficient is x to the power of 12, y to the power of 13. First, you know that this is an element of the expansion because when you add the two exponents, that's 25, it matches our n. So that's actually one thing you may consider in finding the coefficient if it satisfies one of the terms in the expansion. Now, with this form, following this form here, which is x to the power of n minus r and y to the power of r, we can now solve for the value of r. And our r is actually equal to 13, as that is the exponent of our y, or the second term. Okay, so it's y in this case, but in the next few examples, we'll be using other terms aside from 1x or simply x and 1y or simply y. At the same time, you can also verify it here, since x to the power of n minus r is equal to x to the power of 12. That would mean n minus r is equal to 12. So basically, your n is 25 minus r is equal to 12. You will get r, which is 25 minus 12. Still, it will get you or give you 13. So with this now, we are sure that our n to be 25 and our r to be equal to 13. So we can now plug that in this formula. Simply, I mean, not necessarily formula, this is the expansion, okay? But we simply look for this value, the n combination r. Or in short, simply take the 25, which is our n, combination 13. The result of this will give us the numerical coefficient of this term. So simply take the value of that. If you have your calculators there, you can automatically, of course, solve for the result. Again, you try to input that in your calculator, 12 combination 13. And whatever the result, that actually gives us the value for the numerical coefficient of the term x with the literal coefficient x to the power of 12, y to the power of 13. That is actually 5,200,300. This is the numerical coefficient of x to the power of 12, y to the power of 13. Of course, we don't need that because we're only asked about the numerical coefficient. So I'm going to erase this so that it will be clarified further. By the way, for some instances, as mentioned, it will be prepared in separate video where our x, or I mean our first term x and y term y has corresponding numerical coefficients, let's say 2x, then plus 3y, or 2x minus y, or 2x plus y squared. And of course, it will be different now for our situation, but for the previous two examples, you will be including the entire coefficient here as you take it x to the power of 12 and y to the power of 13, because this value will still be improved if the numerical coefficients of our first and second terms are not equal to 1. Okay, so we'll have an example for that in the next few video. But this time, the result here is that the numerical coefficient of x to the power of 12, y to the power of 13, with n equal to 25 and r is equal to 13 is 5,200,300. Thank you very much for watching.